So hey, good morning everyone. This is the 8th lecture of our geometry algorithm playlist. So today's question is area of intersection of two circles. So we have given the coordinate of the center of two circles x1 y1 and x2 y2, as well as the radii of respective circles r1 and r2, and we have to find the common intersection area. So this is all about questions, and here we have to given x1 y1, this is a center of one circle and the radius, and x2 y2 is the center of another circle and r2 is the radius of that circle, and we need to find the intersecting areas between them. So first we will understand the concept on approach, how to solve this problem, and then we move on coding. So same question I have written here also. So given the coordinate of center of two circles, okay, so I have made already two circles. So let the center will be c1 and another center will be c2. Their coordinate are x1 y1 and another coordinate will be x2 and y2, okay, and added two radii is given. The radius of first circle is r1 and radius of another circle is r2, and this is the intersection area. This shaded region, we need to find the area of this shaded region, okay. So what the approach we will be following? So for solving this, first approach is to find the distance between c1 and c2. So we will simply use an Euclidean distance formula. So if 2 point is given and we have to find the distance between them, then what will be going to show? x2 minus x1 whole square plus y2 minus y1 whole square. So first calculate this value d, this is the distance, this distance I have found, okay, and then find the let's given the point is x and the given this point is y, okay. So I have drawn a sector. This sector, this is c1 and this is x and this is y. So this is this region, this and this, okay, the same drawn here. So first we will calculate the area of this sector, whole shaded region, and then find the area of c1, x and y, and subtract the value of this triangle area minus in this shaded region. Then we find the area of this region. So this will be the region, okay. So for calculating the area of whole sectors, we need to find the angle, this x c1 y, and similarly the x c2 y, okay. So this formula, I will write this formula directly. I have written already, yeah, here. Let this angle is alpha, okay. So the formula of this angle is cos inverse r1 square plus this distance d1 square minus r2 square upon 2r1 into d into 2. This is a common formula, okay. So if you can't understand, I will write here also. So this is cos inverse, okay, is r1 square plus d square minus r2 square upon to r1 d, here also multiply by 2. This is come with this also, sorry, this come with this. Okay, yeah, this is the formula, okay, alpha. And similarly the beta is, this is the beta formula, beta. Similarly this beta will be cos inverse r2 square plus d square minus r1 square upon 2 r2 d and whole multiply by 2. So this is the two formulas we will be using. So if we know the the value of alpha, then what is the area of this sector? So we understand if any circle is given, and if we want to find the area of this sector, if this angle is theta, then what is the area? This, sorry, not whole sector, sorry for that. Okay. Area of only this region. So area will be, we know the general formula is theta square upon 2 pi, let the radius will be r, okay, so into pi r square. Okay, this is the formula of whole sector. Okay, similarly this is also a part of you can, if you look into it, you understand this is a one sector. Okay, so similarly the formula of this whole sector, let A, okay, the whole sector will be, if you remove, so this is alpha square, sorry, not a square, sorry for that, this is only theta angle, okay, sorry. So alpha by 2 into, what is the radius? This radius is r1, is r1 square. Okay, this is the area of whole sector. And what is the area of this triangle? So another one important formula is also, so this, if this triangle is given to us, okay, and the angle is, let's say, alpha, and the side is A and B, okay, so what is the area of this triangle? So we know the area of this triangle is 1 by 2 A area of this triangle is AB sine alpha. We know that. Similarly, so I will go here also. Okay, so what the area will be, common area will be, so area of we have already found the area of this sector. The area of this sector A, this was alpha by 2 into r1 square, and the area of triangle A, let's say it is 80, that will be half, and this is alpha, and this is the both side will be same, r1 and r1. So what will be, so half r1 square into sine alpha. So what the area of the, so now we find the area of this region, this region. Okay, so the area of this region, this half part is, let's say it's a small a1. Okay, so the what will be the area of this region is a minus 80. Okay, so alpha by 2 r1 square minus half r1 square sine alpha. Sine alpha. So this is the a1. Okay, this is the formula we will be using, this is the formula we will be going to use. Okay, so similarly, if we find till now we have find the area of this sector. So if we want to find this area of this sector, this left sector, so similarly we can find using same method. Okay, so I will write directly the formula. So what, let's say the area of that sector, this sector, you can see that. Okay, so this half sector. Okay, so area of this sector will be beta into r2 square minus half r2 square into sine alpha. And the final area of this common sector will be what? So common sector will be equal to, total sector will be a1 plus a2. So that will equal to alpha by 2 r1 square minus half r1 square sine alpha plus beta by 2 r2 square minus half r2 square sine, oh sorry, here I have done a mistake here. This will be not alpha, this is a beta, because the angle, I am explaining, the angle we have taken here is beta. Okay, that's why this will be a beta. Sorry for this. Okay, so this is beta. So this is a formula of common intersection area. Okay, this is the main formula. Okay, so here we use some hack also. This is a general formula. So when we use when we doing coding, okay, so when we doing coding, so we need some more approach also here. So let's say this is the common formula, so this we will be using this also. So let's say this is, why I am making this, okay, let's say this is the radius r1 and this is the radius r2. Okay, and the distance between this is d. Okay, so what if d here, okay, so first is if D is far greater than sum of R1 plus R2. So in that case, the both circle will never intersect each other. You can see also, if what is the worst case, if both circle will be touch each other. Okay, so what will be doing, this radius is R1 and this radius is R2. So when D equal to R1 plus R2, it means this both circle will touch each other. But if D greater than R1 plus R2, in that case the both circle never going to be intersect each other. So in that case the common intersection area will be 0. This is the first condition. Okay, and the second is if D less than or equal to R1 minus R2. I'm using this. Why this is happening? Thickness is, I think. Okay. So this D is less than equal to R1 minus R2 in and one more condition, if R1 is greater than equal to R2, in that case we can say that whole circle, if R1 is greater than, in that case we can see that this circle, this circle will be inside this radius will be R2. Radius of this circle is R2. Okay, so in that case the common intersection area will be this only, this area of section. So what the area is, pi R2 square, simply. And similarly if D less than equal to, okay, I don't think so it's visible to you. Why the thickness is okay, I know, I got to know, because of that I have resumed. Okay, so in that, if we take, let's take this D, if D is less than equal to R2 minus R1 and R2 is greater than equal to R1, what going to happen in that case? In that case, let's say this radius let's say this is the radius of R2 and this is the radius of R1. Okay, so in that case what will be going to happen? So in that case the distance between D to D means this center, let's say this center. Okay, this will be D. So D will be far less than or equal to R2 minus R1. Okay, and the R1, this is R1. So and R2 is greater than equal to R1. So in that case the R1 circle will be lie inside this circle. So what is the common area? If we say this common area will be A equal to pi R1 square. So that's it. So we have seen four condition. So first condition is if D greater than R1 plus R2, in that case the circle never intersect each other. Okay, and if second condition is if D less than equal to R1 minus R2 and R1 greater than equal to R2, in that case the answer will be, the area will be pi 2 square. And the third case is if d less than equal to 0, sorry, not less than equal to 0, if d less than equal to r2 minus r1 and r2 is far greater than or equal to r1, in that case the common area will be pi r1 square, because this circle is lie inside this. And the fourth condition is what I have derived here. This, the fourth condition is this, okay, this area. If none of the three condition is fulfilled, in that case we will be using this general formula a1 plus a2. So okay, so that's all the conceptual parts. Let's move on to the coding. So what I have discussed, same thing I have written here also. So we need to find the area of intersection. So this is the x1 and y1, and the radius is r1, and second circle's radius is x2 y2, and the radius is r2. So what will be going to first calculate? We will be going to first calculate Euclidean distance between these two centers. Okay, so that is d. So d is square root of x2 minus x1 whole square plus y2 minus y1's whole square. This is a simple formula. And same condition I have applied here also. So if d1 is greater than r1 plus r2, so what will be the answer? Common area, it will be 0. And if d is less than equal to r1 minus r2 and r1 is greater than equal to r2, then in that case the area will be pi r2 square. And if distance d is less than equal to r2 minus r1 and r2 is greater than equal to r1, then in that case the area will be pi r1 square. And if none of the condition will be fulfilled, then the area will be the general formula I have derived. So alpha equal to cos inverse r1 square plus d square minus r2 square upon 2 r1 into d into 2. So that the same formula I have written here also. So alpha equal to cos inverse this formula, and beta equal to this formula, and then the area a1 is this. So similarly same formula is written here also. Same thing, alpha, and I have calculated alpha, beta, and then area will be the shaded region minus the area of triangle. That's it. So let's compile it. I have discussed all the things. Yes, the answer will be 7. So let's submit this code. Okay. Oh, so this is the question. Thank you so much for watching this video.